All right, today we're going to be talking about variables and graphing. Graphing is something very key to science. Whenever we've done a science experiment, we need to have a way to share that data with somebody else. So a graph is a good way to do that because it's universal. It can hand it to anyone and it should mean the same thing to anyone across the globe. So we're going to be talking about the different variables you have today and how to record those variables on a graph.
Okay, so what type of variables are there?
Well, there's going to be independent variables and dependent variables. Okay, the independent variable, if I do a science experiment, it's what I am changing. It is what is manipulated. It's what's changed on purpose. A dependent variable is going to be the result of the change that I did. It is what is measured, what is observed. It's called the responding variable.
Okay, so if I know my dependent and my independent, how do I put this into the graph?
Okay, good question. We can take a look at our graph here. All right, we're going to use a trick called dry mix to know where to put what.
Dry mix.
Dry mix. D stands for dependent. R stands for responding on the y-axis. So your dependent variable is going to go on your y-axis.
Dependent or responding on y-axis.
Okay.
Okay.
And your manipulated or independent variable goes on your x-axis.
Or independent. On x-axis?
On x-axis. So we're going to be talking about, use an example of boiling water. Okay, so we're going to take room temperature water and put it on a hot stove. What I'm changing here, what do you think is going to be my dependent or my independent variable? What am I changing?
What are you changing? You are going to be changing the length of time on the stove?
Right. So the longer I leave it on the stove, the hotter it's going to get. So then that temperature is going to be my dependent variable. So the temperature of the water is the dependent. How long I leave it on the stove is the independent variable.
Oh, okay.
Okay. So let's go ahead and write an example graph on this.
Okay, I've got a graph.
Okay, great. Let's actually go over some rules for good graphing first. Okay, I've got a trick to remember this called tails. T is the title.
Title.
Every good graph needs to have a title on it, so that way whenever you look at it, you need to know, you can see what this is actually about. You don't know if this is boiling water or how long to throw a football or whatever. So you need to have a title that explains exactly what it is.
So we need to put a title on this graph.
Right. So a title for this would be how long it took to boil water.
Boiling water. Okay.
Okay. So A stands for axis. So that's knowing which axis is the dependent variable and which one's the independent variable.
Okay. So we decided that the time was our x-axis, right?
Right. No. Yes.
Okay.
Time is the x-axis.
So should I go and label it?
Yes. We can go ahead and write time. And then our y-axis is going to be our temperature. So the x-axis is our manipulated or independent variable.
Okay.
Okay? All right. So our next one is intervals. T-A-I. I stands for interval, which is if we boiled water up to 100 degrees, we started it at, say, 70 degrees. Okay, we're going to take a look at our graph here and say, okay, it started at 70 and wound up at 80. So I've got 1, 2, 3, 4 points here and go 70, 80, 90, 100 pretty easily.
Gotcha.
Okay.
And that was for temperature?
Oh, yes, temperature.
So,
So
70, 80,
80,
90.
90,
And
and then 100 would go above that. We don't actually have to label that one.
okay.
So, but we can put our time would be like 5 minutes, 10 minutes, 15 minutes.
So it goes in fives.
Right.
10. Will it always go in fives?
No.
Okay.
You have to look and see how long it took to boil the water. If it took 5 hours to boil the water, 5 minutes would not be inappropriate.
Okay.
Because then the minutes would just keep going on and on. You need to choose an appropriate amount for how much space you have.
Okay.
Okay? So, L is labels. You need to make sure you have a label on both X and Y axis, which we've already done, so this could be just a checkup for you just to make sure.
Well, this
you
would be
have
a good place to put our units too, right? Because we
Yes.
were measuring in seconds or minutes or hours.
Yes, we were measuring time in minutes.
Minutes. Okay, so we'll put minutes in there.
Okay.
And our temperature?
In Celsius.
Oh, it's right. We're in science. We always have to use Celsius.
That
don't
is
we?
correct.
Okay. And then what's our last one?
That is scale.
Scale.
Scale is making sure that our smallest number and our biggest number on this graph is appropriate for the information we're trying to represent. It wouldn't make sense if our water boiled at 20 minutes. It wouldn't make sense for our time axis to go all the way to 200.
Oh, okay. Because then it'd be hard to see everything. It'd be too small.
Exactly.
Okay.
So the scale needs to be appropriate for whatever data you're representing.
Okay. So then you're telling me by using the dry mix method and by using tails, I'll always be able to figure out where my variables go and how to build a good graph.
Mm-hmm.
Okay.
So now, to build this graph, to continue building this graph, we're going to say, okay, at 5 minutes, we were at 70 degrees. So we're going to put a dot there.
Put it up.
Okay?
Okay.
At 10 minutes, we were at 80 degrees.
Okay.
And at 15 minutes, we were at 90 degrees.
Okay.
So now we can draw a line of best fit.
And that means the one that fits through all of them?
Fits through all the
Like
lines.
connect the dots?
Connect the dots, but you want to make one an average, because sometimes you'll have a dot up here. Sometimes you'll have a dot down here. Sometimes you might have a dot over here.
Okay.
But the line of best fit is going to be like the average in between all of them.
Oh, okay.
Okay? So it needs to be a straight line, and it needs to hit as many dots as possible, or be as close to as many dots as possible.
And what is the straight line going to tell us?
The straight line is going to tell us, it's going to be able to interpret or interpolate the information from the graph. So this we can tell, okay, at 7.5 minutes, we can figure out what temperature it should have been.
Oh.
So we can take this area right here, which is about 7.5 minutes, go across. What temperature would that be?
Oh, that would be like 75.
About 75 degrees, right?
Mhm.
Okay. We can also extrapolate information. We can go further. If this graph, we could say, okay, our graph ends here at 15 minutes, but we can kind of go on with it at 20 minutes. What temperature would it be? What temperature would it be at 30 minutes?
Oh, okay.
Okay?
So that's why we need graphs.
Right.
So we can see our data
Mhm.
and figure out what we're going to see in the future.
Exactly.